sorry about the delays. Can you hear me in the back there okay? Mark, are you here somewhere? Good, finally. So I'm here today to talk about the Aarch32 project. So I think we should call it Arch, as in aardvark, to get around Mark's pronunciation problems. So what is Aarch32? Well, Arm32 comprises two instruction set architectures, Aarch32 and Arm64. And individual implementations can choose to implement either Aarch32 or Arm64 or both. Okay. So I work for a company called Lenaro. Anyone who's not familiar with Lenaro? Lenaro is a not-for-profit organization, and its goal is to improve the state of Linux on ARM devices. And behind this is my name and job title. I'm a JVM engineer, and my personal goal is to improve the state of Java on ARM devices. Okay. So one of the things Lenaro does is it specifies a reference design for development boards. And the goal is to provide low-cost development boards to support development for Arch32 and Arch64. There are two variants of the board. There's a consumer edition and an enterprise edition. So the specification of the consumer edition is here. It's an ARMv8 with Arch64 and Arch32 instruction sets, 8-core 853. This is painful. 8-core 853 processor, 2 GB memory, and that's available for $99. And you can get a reference to that if you go to the website, which is 96boards.org. The Enterprise Edition, available really soon now, is a 4-core, but it's a 4-core out-of-order processor as opposed to the one here, which is an in-order processor. Up to 16 gigabytes DDR, and it's got SATA and 1 gigabyte Ethernet. And the total price of that is $99. So this is a bit limited with 2 gigabytes of memory and without the SATA and Ethernet, so you may want to wait. I would just like to point out that Lenaro makes no money from the sale of these boards. So I'm not plugging the boards so that we sell our boards. They're ordered directly through the site. Okay. So, actually, I'll look at this. So there's been a long history of Java development on ARM, starting in 97, 98. The timescales were approximately. We started with Java OS, and that was based on JDK, called 1.1.3 through to 1.1.8. And then we ported PJava on top of VxWorks, that was based on 1.1.8. And then we started the project Giselle Hardware Acceleration to execute the bytecodes directly in hardware. That was a fun project to work on, and it took about 3 years to get that working. And that was on a variety of technologies, JDK 1.1.8. And we were also looking at JTME, CLDC, CBC, and those were based on KVM and CVM. In 06, 07, that sort of time frame, I'm not sure exactly when, OpenJDK was opened. And then in 2009 and 2010, I did a port to the JIT. It was a small, fast JIT. In 13 to 16, the Arch64 port. And there's been numerous third-party support as well, JamVM, Kakao, probably others. Despite all of this effort over almost 20 years, and 10 years since OpenJDK has been open source, we still have no open source port of hotspot for Arm32. So that's what this project is going to address. So at FOSDEM last year, at the end, I proposed the idea of the project, and I asked for a volunteer to come forward to lead the project, and as is usual, nobody came forward, so I ended up doing it myself. So The goal of the project is to provide full-featured support for JDK on the Linux Aarch32 platform, and Aarch32, and the port will be fully compatible with Arm32. Okay, Aarch32 is almost 100% compatible with Arm32. Arm claiming 100% compatible, but it's changed my binaries from Arm32 to Arm32. The problem is when they say 100% compatible, what they mean is 100% compatible with the non-deprecated instructions. So the instructions that were deprecated in Arm32 are no longer in Arch32. But there are very few of those. They're basically the DNB, ISP, and the cache flushing instructions. It's relatively trivial to get things working. The full report came out in November 3rd. That was 17th. It was approved by 4 votes. The minimum number required, I believe, is 3 votes. So that was 1 vote place. Sadly, I wasn't even allowed to vote for my own project because I'm not an open JDK member. So that's a hint to anybody who wants to nominate me, by the way. No pressure. So the project was created on December the 7th and initially uploaded the JDK 8 and JDK 9.3. And the project page is there, so you'll all be able to see the project page. It's the obvious project page. This project is not formally sponsored by Lenaro, okay? But Lenaro are allowing me to spend some of my spare time on this project. And they also allowed me to hire an intern for a period of 3 months last year. So I hired the intern, and his name is Joseph Joyce, and he worked with us for 3 months. And initially I was setting the goal that, well, in 3 months it would be nice if we could get it to print out something that looks vaguely like a template interpreter, even if it doesn't run. In the typical way of interns who, when they're not told that it wasn't possible to do on scale, he went ahead and implemented a typical template interpreter for 3 months, which was good, and he's done a sterling job with that. So that has been pushed now to the Aarch32 JDK 9.3, and it has also been backported by Azol Systems to the JDK 8.3. And I'm delighted that Azol, anybody from Azol here? No? Okay, well, thank you very much, Azol. We're delighted to have them on board and delighted to have them helping with this project. There are a number of design choices Joseph made when he was doing this. He based it on the Arch64 project, which was in turn based on the x86 project. And he tried to minimize the changes as much as possible. There were a few changes. He made some changes to the frame structure. And instead of having the frame pointer pointed to itself, he had to point into the PC, and I quizzed him on this, and it was apparently an attempt to get GDB to unwind frames correctly. Sadly, it didn't work, so we might actually reverse that change so that the frames are consistent with Do you want to go back to the first one so you can see them all, or shall I just continue and if there's anything? It's a lot better than it was. Okay, at least I can talk to the slides now. He also made the decision to use the machine stack pointer as the expression stack pointer. On Arch64, those two are separate, and it's a lot easier to keep them separate. Particularly to make debugging a lot easier. When something goes wrong and you're using your stack pointer as your expression stack pointer, that's a wrong debugging. But the reason he made that choice against my recommendation was because of the limited number of registers available on Arch. So here's a sample template, which Joseph presented at the Linaro Connect conference in September of last year. It was rather unfortunate that he chose to present a template which had a button. Okay, so, and anybody's talk about it. I'll give you a few seconds. Okay, well this bug has occurred in every VM that I've worked on. And it is in fact difference in the specification that you can see in Java on what happens with the shift. In particular, the shift values. Java requires shift values in the ASCII So the same happened in the Arch34 port, different variants of that bug. On the Arch64, I believe it always masks it with 63, regardless of whether it's a long But you can feel better because nobody at the Connect conference supported it either. So, it's running, and we've got some benchmarks. For a benchmark, I've used endlessly grinder benchmark 1.0. It's a very old benchmark, but I use it because I can run it in 5 minutes as opposed to something like I don't understand people who write benchmark tweets that they can't just run. It gives us a good idea of the relative performance of the legend. Okay. The blue bar is 0, the red bar is the template interpreter, and the yellow bar is the Arm assembler interpreter, which is part of the microJIT. Okay, and the basic overall average, the last 3 bars here, which you can see show the overall geometric mean, and you will see that the template interpreter is about 50% faster than 0, and the assembler interpreter is about 50% faster again. So, the question is, why is the Arm assembler 50% faster than the template interpreter? The template interpreter captures the top of stack element in a register. The Arm assembler interpreter doesn't. Now, I've found that doesn't actually gain that much as we talked about in the register. The biggest performance interpreter is mispredicted branches. If you look at this sequence here, every single bytecode that you get is a computed branch branching to a completely different destination every time, and it's mispredicted every time. So the Arm assembler interpreter gets around this by chaining up to 4 bytecodes together as a single operation. So for example, iload, iadd, istore is done as a single template. And it does this by using a 4-level deep dispatch table. So in the first level of dispatch, if the bottom 2 bits are 0, it's some sort of complex bytecode invoke or something like that. So it just executes as a single bytecode. Otherwise, if the bottom 2 bits are non-zero, it contains the length of that bytecode. So the dispatching code can get the next bytecode. The dispatching code will get the next bytecode, and the remaining 30 bits of that point to a second level dispatch table, and so on. You can carry up 4 levels. Then when you finally got the address of the routine, you can jump to that routine and do all 4 operations in a single instruction. So why do you want to do this? You know, when we got a JIT, well, having a faster interpreter benefits the JIT because you don't have as much pressure to compile methods if you have a faster interpreter. Possibly in future include this in OpenJDK, maybe. I think it would be quite a big thing to get into OpenJDK, and certainly for the Aarch32 port, we're going to stick with the template interpreter. Okay, but it's an idea for the future, an interesting project, maybe, but I've got lots of interesting projects. So some comparisons then with the Arm microJIT. So we can see typically the microJIT gets about 5 times the performance of the assembler interpreter, and this looks quite good until we go to the next slide, where we put in, and this is a question we asked in the presentation last year. What is the comparison against the microJIT? And here we see that suddenly we have rather a steep hill to climb to match this performance. So this is really why I have made the decision not to continue with the it cannot ever get anywhere close to that. And the main reason is because of some of the design choices that were made in the microjet. In particular, I decided to have the exact same frame frame structure as in the Zero interpreter. And this made it much easier in many ways because the task of the optimization was a null task because it was using exactly the same frame structure. Unfortunately, the frame's got 11 words or something like that. So it means every time I call a method, we create an 11-word long frame. Coupled with the fact that it doesn't do inlining, it gives a huge penalty performance on the microjet. So I think the best thing to do is call this end of line for the microjet and continue and focus on full. Sorry, I didn't. You're missing the legend. So with the same tree as before, green is the ARM microjet. Okay, so it's the JIT I wrote for Arm32. It's a small, quick to compile, slow execution JIT. The red is then the Oracle 8U65 client, and blue is Oracle 8U65-7. This is the Oracle binary because it's Arm32. There's no. Yeah. If you want to make it open source, really, that would really be very nice. Yeah. I know it's not your decision, but if you did have any influence, and
George can be, he's not here.
Okay, so what's this current status? Well, the template from Periphery is quite a good state. It runs quite a wide range of programs, Java, C, Eclipse, something else I've forgotten, that's on the right-hand side. Importantly, a good start itself, always a good start for a compiler. Running through JPEG and we get a few more failures on hotspot. They're not really relevant because hotspot tests make assumptions about the presence of C1 and C2. Since they're not present, most of the errors here are just due to time. It's so slow. That's but the good thing, which you can't see over here, is on that view, it's going to get one failure. Going to have to investigate that. So what needs to be done? Well, it was written in 3 months by an intern. It's in the stream of consciousness, so it needs a good cleanup. The mapper assembler needs to be fleshed out fully with all the ARM instructions. Support for FOSDEM, that's really important. At the moment, it generates the old Arm32 with ARM instructions. Should we go for 22 to be debated? Support for ARM-v6, so the major motivation for ARM-v6 I think is rather high. I don't intend to look at this, so unless someone can call me and do this, that won't get done. Testing and bug fixing, and then 2 simple items here, implement C1 and implement C2. And I have started looking at implementing C2, and I've created a stubbed out Arch32.ad, which builds, but falls over straight away, as expected. We have some promise with some help implementing C1 from one of our partners. I won't mention who, because it's his hopefully, over the next year, we can see a lot of progress on it. So the final thing is a call for help. Okay, this is a community-driven project. I am doing this as a part-time effort within Linaro. Without the community involvement, it's not going to happen. So please join the mailing list and get involved, and the address of the project page is there. Thank you. Any questions?